Hi everyone, so welcome to another step vid. This one on step 1 2005 question 12. Apologies I haven't been doing as many as I was hoping. I was hoping to do a step a day to keep the D grade at bay, but yeah, in the end I just haven't managed it. I need to do some more step 3s for Dylan, but I also need to do some more step 1s for any of the year 12 students who are thinking about doing this paper. Now is the time to start, it really is, and especially over the summer when you're not doing as much. You know, just doing a little step question here, there and everywhere, like one a day or one every other day, really good for you. Even if you don't end up taking the extension papers, it's really good for your A-level scores, you know, it's just because these questions are so much harder. So this was one I suggested doing because I was pretty sure, and I was right actually, that there's nothing in here which the students in year 12 shouldn't be able to do, even if you're in my AS class. This is just conditional probability in Venn diagrams, that's all it is. And actually you can do a hell of a lot of it just doing that. Now obviously it's worded more differently, and if you look actually at the examiner's comments, this question was answered very poorly. It's what they lead with. In part A, almost every candidate assumed they were independent at the times the probabilities together. Very rarely saw a Venn diagram. It seems obvious to me that it should be done for a Venn diagram, but it doesn't sound as bad as question 14 where it literally says no one got this right. That's funny. Okay, so let's have a go. And this is the third time I'm shooting this video. I'm having some video problems at the moment, so hopefully it works this time. So it seemed obvious to me to draw these probabilities overlapping, because you could smoke a pipe and wear a hat, or smoke a pipe and not wear a hat, or wear a hat and not smoke a pipe. So Venn diagram just seemed obvious to me. Never assume things are independent, because what evidence have you got for that? Now we'll have A as smokes pipe and B as wears hat. Okay, what's going on here? Well, they told us that the probability that they smoke a pipe but does not wear a hat is P. So this is not wearing a hat but also smoking a pipe, because A is smoke pipe, B is wears hat, so not wearing a hat, smokes pipe is P. Which means if A is 0.7, this bit needs to be 0.7 minus P. Which means this bit, well, this needs to add up to 0.4, so we need a P to get rid of the minus P when we add it together, and then we need to take away 0.3. Now that plus that equals 0.4, so it's consistent with the information given. And finally, add all of this up, you get 0.4 plus P, so this outside bit must be 0.6 minus P, so that every single bit adds up to 1. Now, determine a range of values of P consistent with this information. Well, this inside bit needs to be positive, in which case we can say P is definitely less than or equal to 0.7. The B bit needs to be positive, and so that means P is greater than or equal to 0.3. And lastly though, do check the outside as well, because you get a strict condition here. As this needs to be positive, this tells us that P is actually less than or equal to 0.6, which beats that one, because if P is both less than or equal to 0.7 but also less than or equal to 0.6, then that's redundant. And so you can give the answer, 0.3 is less than or equal to P, which is less than or equal to 0.6. And you're done. Okay, typical step here. A is kind of like a warm-up to B, where they're going to get you to do it with 3 events this time. Okay, so I started drawing out a Venn diagram, and can I just say, I was alright with this bit, and I was alright with this bit. I messed up the last bit at the end and only got it kind of half right, so I don't think I would have got full marks. In fact, I'm certain I wouldn't have got full marks in exam conditions on this question. Quite a tricky one. As I said, it was very poorly answered in the exam. Now this time we've got wears hat, wears a cloak, wears a ring. Yeah, and so they tell us that the probability that they wear a hat, and cloak, and a ring is 0.1, and the probability that they do not wear a hat, do not wear a cloak, and do not wear a ring is 0.05. So we get those regions, and then we've got to work out the probability that the wizard wears exactly 2 of a hat, a cloak, and a ring. Now that is these regions here. Flowers, yeah, because this is hat and cloak and not ring, this is cloak and ring and not hat, and this is ring and hat but not cloak, and so you definitely need those 3 regions. We want to look for that. Now I called them A, B and C, A, B, C, and then I thought, oh, I can add the information at the top. The probability that a wizard wears a hat is 0.7. Well, this must be then 0.6 minus A minus C. Now all of that adds up to 0.7. Likewise, as this is all 0.8, this needs to be 0.7, because we've already got 0.1 counted, minus A minus B. And likewise, this needs to be 0.3 minus b minus c. Yeah? And now to find the probability that a wizard wears exactly 2 of a hat, a cloak and a ring, well, I didn't see this, but you could certainly just add up all the probabilities, equate them to 1, and then you'll be able to find a plus b plus c, which is what we're looking for, because we want the petals, yeah? We want a plus b plus c. We do not need to know the value of a or b or c to work out a plus b plus c here, yeah? And so the way I did it actually was kind of like, I thought, well, all of this, let me draw a circle around this one. All of that is 0.4, and I could have done this with any of the other rings, by the way, and that bit's 0.05. So I said, well, 0.6 minus a minus c plus a, so that bit plus this bit, plus 0.7 minus a minus b, that must be equal to 0.55, yeah? And then something nice happened, because 2 of those a's cancelled. 0.6 plus 0.7 is 1.3, and then you've got minus a minus b minus c. And when I saw that, I got excited because I realised I'd done the question. If I take that away from that and add all of those onto there, I can see that a plus b plus c is 0.75, and I've finished. Brilliant. You know, so it's all about a good diagram, really. This same with the first bit. How do you do it right? You draw a good Venn diagram. Yeah, it's literally that. Okay, finally, the conditional probability bit. Now, the first bit's fine because it says the probability of a hat and not a ring, given that you wear a cloak, is Q. Yeah? So I changed it immediately to hat and not ring and cloak, and divide it by what you were given, cloak, and said that equals Q. And then I thought, what regions are these on my diagram? Well, let's just shift it over here. We can see hat and not ring and cloak is A. And the probability of cloak is all of that, which is 0.8. And so I thought, well, I know that A is 0.8Q. And so I thought, if I want to find the range of values of Q, consistent with the information, really I want to find the range of values of A. And then I can just times by the reciprocal, well, divide by 0.8, and I've got the range of values of Q. Yeah. So that's what I started to do. Now, I wrote down these 3 inequalities first. I wrote down A plus C is less than or equal to 0.6, A plus B is less than or equal to 0.7, and B plus C is less than or equal to 0.3. Yeah, and that's just because this has got to be positive, this has got to be positive, and that's got to be positive. Now you could, you're always allowed to. Here's an interesting fact about inequalities. You're allowed to add 2 separate inequalities, but you're not allowed to subtract them. Yeah. So if you've got, let's do it with different letters, x is less than y, and p is less than q, you may infer that x plus p is less than y plus q. That's allowed, that's fine. But you may not infer, we're not allowed to subtract them, it's really interesting this, that x minus p is less than y minus q. That's wrong, yeah? You can see it with numbers, yeah? 7 is less than 8, 8 is less than 9, subtract them, you're going to get minus 1 is less than minus 1. Clearly nonsense. If you add them, of course, and clearly they're all true, yeah, you get 15 is less than 17, and that is true. So be really careful with subtracting inequalities. By the way, the reason it doesn't work is because you may only add inequalities, so times them by minus 1 and add them instead, but don't forget to switch the inequality sign. That's really what is the fly in the ointment there. So inequalities, they're hard to handle actually, and that's why they're often tested in the extension papers. So anyway, what did I do? I added these 2 together, the first 2, and I thought 2a plus b plus c is less than or equal to 1.3. But then I thought, oh, hang on, that means that a plus b plus c is less than or equal to 1.3. But as we know that's 0.75, we get a lovely condition on a of a being less than or equal to 0.55. Yeah. Now there's lots of ways you can get a condition on a where you end up with a is less than or equal to 0.6 or a is less than or equal to 0.75, but that's the strictest one that you can find. Yeah, and that's the thing, it feels a little bit like fumbling around in the dark, this last part of the question. Now the other thing we can infer is because of this fact that b plus c is less than or equal to 0.3, once again, if we use a plus b plus c is 0.75, and then we say, well, hang on, b plus c, this bit, is going to be smaller than or equal to 0.3, so that's less than or equal to 0.3. Well, as that bit gets smaller, a needs to get larger, and so we can say, so a is greater than or equal to 0.45, yeah? Because that bit is less than or equal to 0.3, so this bit must grow and compensate for it, because together they must add to 0.75. Okay, that gives us that a is between 9/20 and 11/20, because that's 11/20 and that's 9/20. I'm showing you like this because you're not allowed to use a calculator. Remember, a was 4/5 of q, so now just times both sides by 5, and then divide by 4, you're going to get 9/16 and 11/16, and you're done. Whew. Hope that makes sense. Keep up the hard work. Bye bye.